I do have a very strong disclaimer that it's very important to me to mention. I'm not an author of the reflection proposal, and I'm not an implementer. And the majority of the work, I mean, all of the work is done by them. My part of this is as part of my role as Library Evolution Chair, that we're reviewing the proposal and proposing fixes, etc. But thank you, Anastasia, and I just wanted to make this disclaimer because this is very important. So you should thank them, and you're going to see their names later during those slides. Okay, so first of all, I'm very excited of being here today. I think it's the most northern that I've ever been in Europe, and that's very cool. And I love the weather, so thank you. I did see at least a few windmills and bikes as promised, so all good. All according to expectations. Thank you for hosting me. I am very excited to be here. And also, thank you for the organizers. I can't believe that this conference is running for the first time this year. It's amazing. Everything is, works like a clock, and I'm amazed. Thank you so much for doing that. And can we applaud this? So Andrew, Anastasia, and I'm sorry if I'm forgetting anyone else. All right, so thank you again for coming. I'm excited to start this talk. So this talk is about reflection, as I mentioned. And meta, you're going to understand what that means a bit sooner. But I want to introduce myself very briefly. So as Anastasia already did, I am a C++ developer, and ISO Foundation and Boost Foundation board member. So ISO Foundation is the foundation behind cpppcon. I don't know if you're aware, and they also help making the progress for C++ in general, like, for example, by supporting some of the standard proposals. Also an active member of ISO committee as the Israeli National Body Chair and Library Evolution Workgroup Chair, which is the major reason standing here talking about reflection with you today, because reflection is now heavily being reviewed by Library Evolution. So generally speaking, there's an evolution group and library evolution group in the standard. Evolution are reviewing language additions, and Library Evolution are reviewing additions for the standard library. However, as you can probably imagine, and you'll see by the end of the talk, for sure, you'll recognize that there's a major part of library functions in reflection. So there's a namespace, there's library functions. Of course, underneath they have intrinsics that depends on compiler, but they still require our review. So that's, and additions. And I think on top of that, it's going to be very interesting to see how reflection affects libraries. And I'm also going to talk about that during my talk. So what is reflection really? So I think it's important to recognize first that this is pretty novel. So C++, there's a static reflection in D. When we talk about reflection in programming world, we usually think about things like happens in Python, that you basically explore things on runtime. You have something underneath that is the interpreter, and that basically you can query it and get back answers. I'm simplifying, but this is a bit different, because when we talk about the C++ reflection, and by the way, it doesn't exist in Rust as well. Rust gives you something like similar to type ID, that you get the information, but they don't have like fully static reflection, which is, again, makes this pretty novel. And I also highlighted that this is compiler exposes structure at compile time. And I highlighted compiler because I really think if you get out of this talk with understanding of this sentence and like, what it means for your code, I think I've done my work, because this is really important to keep in mind. So this is something that is done by the compiler, right? That means that when we get to the linker, it's too late. Okay, so it's important, and you'll see why. Few disclaimers is, as I said, we're talking about static reflection done by the compiler looking at your code. there was some ideas of doing things like carry the data into runtime. We're doing other things for runtime reflection for C++, but this is not what we're talking about here today. This is not what is proposed by the proposal that we're now talking about for 26. This is other things, other ideas that could, there's also some notion of JIT, but all of those things are out of scope for this talk and for the proposal. So this talk is going to have two parts. The first part, I'm going to introduce reflection to you. We're going to go through a brief history of what was discussed for reflection previously in the standard. And then we're going to look at the latest proposal that I've mentioned already, P2996, which is basically what we're hopefully and you know, if everything goes by plan, we're going to see in 26, C++ 26, which is exciting. Hope you're excited as I am. Who is excited about reflection? Okay, all of those that are not, you're just here because it's a keynote and you have nothing better to do, okay. Because there's like a very nice weather, but I'm kidding, I'm very happy that you're here. I hope that by the end of the talk you would be excited about reflection. Yeah, so after that we're going to look at some usage examples and we're going to try to imagine how reflection would impact the code that we're using. And the second part, we're gonna have like a more of a wider view of how this impacts our pipeline, our CI, and Anastasia here, I talked with her very extensively about those things, and this is very interesting actually to think about. I hope to prove to you that it might even change the way the CI looks, but we'll see. that might be a bit, you know, just my impression. Okay, so I hope that by the end of the talk you'll get a good understanding of how reflection looks like, what the syntax is, and also how it's going to impact our code bases. I do want to mention again, so there's the P2996 paper, there's P3096 paper that is, the original one is by a large group of authors that we all owe a lot to. Also, there's the 3096 that tries to fix function params that I'm going to refer to when we continue the talk. And there's also implementation in EDG, and EDG, one of the people that works in EDG is also a major author of the paper, so his name is David. He's going to be mentioned a lot during the talk. So all of those I jump between implementations of Clang and EDG, and they're all available in Compiler Explorer, but I still think it's awesome. They're all out there. All right, so to start, the idea of reflection have came up, I think, pretty early in the life of C++. So this is the first mention that I've found for something that actually addresses reflection. And this is a proposal in 2006 by Matoush, Mirror Reflection Library. He's basically presenting a library. But this is probably not what you'd think about when you think about reflection, because this is more of relying more on template metaprogramming as we know it. Still very interesting to mention that it's been reviewed and thought of. In 2012, we got a paper from Mike Spartus, which, by the way, gave a talk in our conference about Cloud API, which is very interesting. I think you should check it out. And he's iterating use cases for reflection. And again, I just want to emphasize that, and again, when the talk progresses, you'll see why, but note that he's already addressing compile time reflection, right? This is important. It's the compiler doing that. Between 2014 and 2016, we got a proposal for static reflection, which basically, and a bunch of other proposals basically addressing the mirror reflection library that we talked about before. Those things have, again, relied on type traits, attributes, those things that are kind of rely on what exists in the language already. And in 2015, we got Boost HANA, which was implemented by Louis Dion. And this is a template metaprogramming library. Okay, so I think that this is significant milestone for how do we understand reflection. But I think it also brought up to our attention that template metaprogramming may not be the best tool for reflection due to, you're doing something that is not within the language, and therefore you pay with compiler performance. The compile time performance is going to be heavy. So that kind of brought up the focus on how do we do reflection in ways that are not template metaprogramming, which led us to 2017. So this is basically the first time that people kind of noticed, or I don't know if noticed, but started focusing on this. And there were multiple proposals, and as you can see, this is like an explosion of interest, talking about reflection syntax. So this, unlike previous proposals that I've shown, this actually tries to give keynote keywords, bake reflection as part of the language. So we have here Matush, Axel, David, Senkel, that you're going to see later, Andrew and Herb. Of course, Herb Sutter is the convener of Worker 21. And David, that I've mentioned before, is actually a very active author, and Louis Dion, that I've mentioned. So all those people propose kind of different syntaxes, but still trying to bake reflection as a keyword. And these also introduce the meta-object idea. So when you reflect on your program, right, you basically try to look at your program, get information. The reasonable thing to do is to save this information in an object, right? An object that represents pieces of your program, for example, a variable or a type. And this is exactly what meta-object is. So you're going to look at the syntax, and we're going to talk about what the meaning of this object and what can you do with it. But this is basically where it came from, and that makes a lot of sense, right? And in 2018, of course, Bjarne joined the party, so now we have more focus on those, on those proposals and the reflection aspect in general, and I think it really shows you how much interest that created. In 2018, there was also the reflection TS by David Senkel that I mentioned, and TS is technical specification, so that would now be kind of a document that actually tries to specify with details, not just a proposal for a single feature, but basically trying to do something more comprehensive of how real reflection look like. This did not materialize into the standard, but some ideas from here, and I think a lot of the research, have actually materialized into the proposal that we're going to talk about today. And again, with collaboration, there was value-based reflection and scalable reflections coming from the authors that we saw before. Again, all of those people are very strong technical people and leaders in the committee. And this also exposed some other dilemmas that existed. So again, try to imagine how would you implement something that explores your program. So you have some expressions, you have some objects, and you want to represent them. So you could technically create this hierarchy of types, right? And preserve, Bryce talked about very interesting things regarding sub-expressions and expressions and full expressions. So you could imagine that expression is like the hierarchy base, and then you have sub-expressions and etc. And that you would call like type-based or fully typed or other terminology that's been used in various places in those papers. But it turns out that this would be heavy for the compiler. So compiler implementers that are, again, heavily involved in this because they care about this a lot, because basically they are the ones that's going to go and implement this very, very heavy feature. So it turned out that they found out that this is too heavy to keep this full hierarchy typed. So what we ended up with is something that is called value-based or monotype, or which is basically a type that holds the information, but it's a single type. It's called stud meta, and you're gonna info, and you're gonna see it later in the slides. Still think it's interesting to consider. Right, so Yes, and I did mention there was a lot of collaboration, so I just wanted to show you also compromise paper. And by the way, of course, all of those, there's links, and you can go and read them if you're interested. So there are a lot of compromises done, and a lot of different opinions on this topic. So another thing that I find interesting is that there's a lot of debate on the syntax of reflection. And again, we ended up with something that you're going to see today, but it doesn't mean it was the first choice. And there was a lot of whether you call some kind of a function syntax, so you call like, I don't know, reflect, and then you give the expression. When you do other things, how do you call those operands? I think these are also things that if you just sit in front of a blank page and try to imagine and design this feature, you probably, if I take a group, people here, you're probably going to end up with a completely different design for this feature that we all have in mind. And I just want to give you a hint of how much work it is and how many design decisions were made. Okay. At 2021, I think it was also a significant milestone. We got log 3 implementation, which is basically being done by Wyatt, David, and Andrew. I think at that point, Wyatt didn't work it worked for Andrew. But yeah, log 3 is a company that basically released the first implementation for reflection. And I think that was pretty significant because now we know that this thing is implementable. Now we know how, what's the limitations and what's the things that we need to consider. And again, I refer to value type, etc., which are a lot of considerations to be made there. So we end up 1 year ago, in October 2023, with the proposal that we're going to look at today, and I think it's super exciting. And this proposal is by Barry Resvin, Wyatt, sorry I forgot his last name, Peter, Andrew, Faisal, and David. And I think there are other authors. Oh, Dan Katz is not here because it's not an original version. And this was proposed in 2023 and is targeting C++26. So I hope, again, you're excited about this because I think that, if we're actually going to get this, it's going to be groundbreaking. A few other things that I want to mention before we finish this, because we got to today, basically, 1 year after this proposal was initialized. I do want to mention that there's a lot of other people that have been working on, solving some issues that came up or just giving use cases, like bindings are a very strong use case. I don't know if any of you have ever done, worked on binding. How many of you worked on binding between, I don't know. How many worked on binding with Python? Actually, all of you that worked on binding, keep the hands up. And how many worked on, I don't know, something else like, I don't know, calling functions from C# binary, whatever. Okay, cool. Okay, so that's pretty, I think around half of you worked on things that are related. And the hope is for reflection to make those things easier. And you can definitely see how that connects, or if you're not yet, you'll see by the end of the presentation, I hope. How many of you worked on parsers? Like things like proto, I don't know, internally implemented things like protobuf. Okay. So that's also relevant, right? Because if you could reflect, cool. So I hope you by now understand how effective this thing. So I kind of hoped that everyone would raise their hands when we talked about parsers. But okay, that's still good enough. All right. So last thing I want to say, So I hope, first of all, I hope that by the end of this history lesson, you now understand how hard this was to get where we are today. And I think it's worth mentioning, and again, thanking all the people that have been working on that. So when I say reflection, I just want us all to be on the same page, because I think that the context here is important. I look at some other code, might be my code, might be someone else's code. In this example, it's a library. someone gave me this header, okay? And it have a class, libtype, and it inherits from, you know, I don't think this have to be encouraged, but it inherits from base 1, base 2, okay? Pretty straightforward. Now, in my code, I want to include this thing, and I also include the meta header, and I want to be able to explore it. I want to be able to reflect on it, right? So I basically call functions, and again, we're going to see all of those things later, but I basically take some object that represents the reflection of this thing. Sorry, I don't know why it works weird. Okay. And then I can call some function that explores the object that I got. And again, all this syntax you're going to see later in the presentation and understand what each of those things means. But generally speaking, I do want you to keep this example in mind, because I do want you to keep this idea of getting someone else's code and reflecting on it and maybe doing some things you know, according to that. But again, you need to also keep in mind that this is something that the compiler is doing, right? So that's going to affect how we're using reflection. And I just want to mention, because I gave this talk in ACCU, and someone asked like if the code works, or all the code works on the slides unless, and also there's links and QR codes, unless I explicitly said that this doesn't work, and this doesn't work because basically this needs, reflection needs to be in const eval, const expect, etc., and not like you can't call this function in the main like that. But other than that, I'll show you later other pieces of codes, all the pieces of codes that are not explicitly being stated not to work. Okay, so what do we actually have in the reflection proposal? So let's start with this, and it's a long list, but yeah. We have the reflection operator. Okay, so you already seen this in the previous example. This is called also the lift operator, or caret. We're using caret. This basically takes something from your code domain, right? I have a C++ program, int a equal 42, and I want to take this a and lift it into the reflection world, because I now want to do things with it that are related to its reflected type, to its reflected entity. And then I have splicers. Splicers are doing the opposite. They're taking things from reflection world back to your code, so you can actually create one of those ints, for example. And again, you'll see examples for all those. Then we have the stud meta info. This is the object that I've mentioned before that actually holds all your information, the reflection information, and meta functions. So meta functions are close to my heart, because those are the things that we're going to review or reviewing already. And this is a whole namespace, stud meta, that basically contains all of those meta functions that you can use in order to get, you know, information from your meta info or from your objects or other things as well. So you have things that are related to name and location, like identifier of. And maybe you know, if you start imagining how do you call entities in your C++ program, is not exactly a finite answer. Like, think about things that are in namespaces. Do you actually add the namespace name to the name of the entity or not? And those things have been heavily discussed. And we ended up with identifier of. There were other versions before of name of and other things that had more controversy in them and might be added later. But again, sometimes contexts matter for the name, right? Source location of. This is pretty straightforward. It returns the source location as you know it in C++. There's type queries. You basically ask if this thing is a parent of, and you can de-alias things, right? Think about what reflection gives you. It gives you a sneak peek into someone else's code, but someone else's code contains things that are not in the C++ model. It contains names. Like, if I have function declaration and parameters have names, I don't care about that, basically, but you would if you start reflecting on them. Other type predicates, so you can ask about something, a member, for example, is protected, is private, or function. You can have all kind of inheritance predicates. is virtual, etc. So this is very similar to type traits in a way, only think about it as a way to observe your code, and also it have, in some cases you have to have compiler intrinsics to actually retrieve this information. Is complete type, we're gonna see this in an example. Some template queries, is this thing a template of? What is the template arguments of? Member queries, so you could basically take a class and you could call members of and get the members of this class. Okay, it's pretty straightforward, but it's still pretty powerful, right? Especially if you're taking a class that is not yours and you start to examine it. Accessible members of, I actually erased, by the way, this slide was kind of edited again to comparing to my ACCU talk because some of the things were modified, some were removed, and accessible members of is also something that was removed because it's kind of dependent on context. And again, you start to think about whether something is accessible at a certain point of your program depends on context, right? Substitute is basically, you can give it things like, and by the way, I don't know if Jonathan is here, but we talked about it earlier. But anyway, it's basically, you can give it a template and you can give it a type, and then you can substitute the template with this type, instantiate it. So, pretty powerful. I would not go to any of those, to each of those, but you can see there's a lot of facilities here. I think it's pretty awesome. You could basically look at the data layout of things, offsets, a bit offset, byte offsets. These return some struct that we defined, alignments, of course, and some type traits. Now, when I say type traits, again, I would go deeper into that, but there's different types of type traits. Some of them are observing, some of them can even modify. We didn't get the second part, but we're going to talk about this later in the talk as well. I do think that the proposal is very powerful, and I expect a lot of those to actually come to the standard library as proposals once the reflection proposal would be released, and I think it's pretty awesome. Last thing I wanted to highlight is, I don't know if you've seen when I clicked this, that this caret turned into 2 carets. So there was a lot of debate on the syntax of reflection. The caret one is the one that was favored, but then it found out to be conflicting with some Objective C++ syntax. So, we're gonna, it's unfortunate. The current official syntax is single caret. And that's what I used throughout my presentation. However, there's some good chance, and actually I think that's what's going to happen eventually, is that we're going to have a double caret due to those conflicts. But this is haven't been seen by Evolution. As I mentioned, Evolution is the group that is in charge of new features, and they haven't approved this syntax, so I didn't want to preemptively publish it. But FYI, if those slides don't work afterwards, try to add another caret. Might work. Because, by the way, the implementations are also kind of, they've been modified daily, on the daily basis. Okay, so that was a very long introduction. Let's look at actual reflection code. How does it look like? How does this behave? So we have here, okay, I'm using auto, and we're going to talk about what this thing is returning. I lift an int using the lift operator, right? And I get back something, okay? And this something is basically a stud meta, a stud meta info object, right? So basically, I said before, I want to lift things from, I'd say, the C++ code domain into the reflection domain. So the reflection expression is basically represents my lifting. So far, so good? Cool. Because really, these are the most fundamental aspects. If you think if this makes sense to you, everything else is going to be very, very simple. So objects can be used as an input to other reflections utilities. As I mentioned before, you can give this our expression into those meta functions. But this thing doesn't work. Anyone wants to guess why the code that I just showed on the screen doesn't work as is? And I've actually told you the answer multiple times. Yes. All right. Yeah. Okay. So the highlighting of the compiler aspect of these things actually worked. Thank you, by the way. That's yes. This thing needs to be. You get an error. You get a meta type variable must be const expr. So you have to do this. You have to add the const expr because we're again talking about things that logic that we're running on compiler in compile time. We can't do that with runtime variables. So that's the first requirement, the meta type. Right? Another requirement is that for the thing itself to be const expr, but you'll see that later. So I already mentioned splicers. So what does this code do? So we get the same line from before. We lift things to reflection domain, and then we use splicers. So feel free to raise hand or just shout. What does this code do? Yeah, declares a variable called A with the value of 42. What's the type of this thing? Right, it's an int, okay? So this whole thing, the type name reflection expression being spliced, sent back to program domain, is actually an int, okay?
There's space between type name and the bracket or not?
You don't need a space. There's no space on the slide, but no. It's actually part of the. It's not a type name declaration. Yeah, there's no space because this is actually sort of hinting to the compiler that this thing can be evaluated to type. I'm not going there, right now, and it can be actually discarded if a compiler can see that by itself. But in any case, long story short, this is kind of hinting the compiler. This expression that I'm, been sliced is actually can be evaluated into type. Yes, but again, yes, exactly. So again, splice extract the expression back to from our meta info thing into our sort of normal program world, right? So we now have basically this whole complex thing is basically an int, and I can create ints from this. So again, I just want to emphasize because I think it's interesting and fun. So I already said that, but what is this expression? The rxper, what is this? Meta object, meta info, std meta info object, yes. That is true. And it basically contains the information to be converted back to int. So it's not just it's initialized, right? It's initialized with the information of I represent an int. What is this? What is this? We already mentioned. Which type? It's an int. Right? Because once you evaluate this expression, you get back an int. It's basically an int. Cool. All right, that was a fun game. All right, I'm on slide 12. Yeah, I think I'm fine, sort of. when do I need to finish, by the way? It's, what? Before 6, okay. I will do my best to get there. No, I actually aimed for 1 hour. I think we're fine. I already had 30-something slides. So we looked at reflection operator, we looked at splicers, we talked about meta info, right? And then what comes next? We're going to talk about all the meta functions. Yay! So I'm going to keep you here until, until 8. Not really. We're not going to talk about all of those. We'll talk about them in general. But before we talk about the meta functions, I want to talk briefly about the meta info object thing that I've mentioned before. So anyone recognize what this thing is? Anyone worked on compilers at any point in their lives? Go ahead. Right. Okay, so this is Clang's AST. By the way, I didn't look at it before I joined the committee. And it's pretty awesome. You can also query things. Clang have tools for querying the AST matchers, and that's pretty awesome. You can run regular expression sort of a thing on the AST of your program. So yeah, AST in short, abstract syntax tree, and this is representing your program. So you can see here a function declaration, you can see a variable declaration, you can see the name, right? The I thing, int I. So sorry if it's a bit small. The program that this represents is basically the thing on the side. and you can see the name of the variable, right? Like AST gives you this information and also the type. So this is pretty, like, resembles, right, what we would imagine that the meta info object would hold. And keep that thought in mind as well, as you did with the compiler, because that helped you solve the previous riddle. Because this is also important when I'm going to ask, and I'm going to show another code snippet, and you're going to have to guess what it does. This is important to keep in mind. By the way, this slide is taken from my previous talk. Let's talk about abstraction layers. If you're interested in looking, it's just trying to sort of observe what you can steadily analyze from a program. I just thought it relates, and I think it's really awesome that you know, a lot of the things we work on right now are basically relating. There's a proposal called profiles, and if you're interested, you can look it up. That also talks about static analyzers. And it really relates to, like, what we can and can't do. So I think it's interesting. Okay, so again, meta info represents this information. Sorry, I don't know why it doesn't jump. So it can represent type and type aliases, functions and member functions, and static data members, or structured binding even, or non-static data members. And a bunch of other things. Template, I've mentioned with substitute, that you can give a substitute function a meta object, which represents a template, and then type, and then it substitutes. Okay. And namespaces. But again, I already talked about some limitations on what you can do and where you can do it, and which, and here you can see an int that declared a equal 42, and you can see that you can lift it into, again, on line 2 you get the meta info object. B is the meta info object that represents this A, and you can splice it, okay, and print, but you can't start meddling with it, right? Because you basically, what you have here, this A, even if you move it to reflection word, you basically have something that is not guarantees at cost expires. So again, there's limitation here that you need to notice, and that you can represent constant expressions, constant values, constant expire values, but not like everything that you want in a program. So I think it's worth noticing. And here it comes, yeah. So the thing here, sorry, I jumped. It will fail. It will give you, you cannot do that. A compiler, here it just print, I think, the value. It will just like go back to basically what A was, and then as you'd print A, it's like you'll write A here. So yeah, but again, this is slides code. This actually works, but never mind. But take this under consideration. Yes, another question. Yeah, you can pass this meta. It's basically, you know what? I want you to pay very good attention to this example that I'm going to show on the screen, and you tell me. So I talked about AST. I talked about meta, std meta info object. I want to show you an example, and I want to ask you what it's going to print. So we already know reflection by now. So we have class R. I declared a class. Okay. And I get the meta info. I lift this and get the meta info object, res1, right? That represents this class. Okay, cool. I now call std meta function, one of the functions that is being proposed as part of the reflection proposal. It's querying whether this thing is complete type. So it's basically taking the meta info object, just like you asked. It's a function. It takes a meta info object, and it queries, is this thing a complete type? Okay, so I only have a declaration. What would this return? True? Okay, so now I complete my type, okay, and I have a class. It's complete, And here I do exactly the same thing. So again, I take res2 and ask, is complete type? And at that point, what would come up here? True. All right, and then I take print3, and I do exactly the same thing, but for res1. Remember, res1 was taken here. Okay, cool. So we have 1, 2, and 3. What would be printed? False, true, false. Wait, okay, so who thinks false, true, false? All right, who thinks false, true, true? Nice. Okay, I think it was a bit more of false, true, false here, and I actually thought false, true, false, right? Because it makes sense. Because I took res at some point up, but actually the answer is that you're going to get false, true, true. And that really relates to what I don't know which one of you mentioned, but that was a reference, and that's a reference to the AST. And the thing that represents this class has now been modified. And even though I took the rest upstairs, it doesn't have a snapshot. It actually have a snapshot into as a reference, sort of. That's how you can think about it. So I thought it was a bit non-trivial. I thought it was worth mentioning and showing people. I will point out, I mean, I think, again, there's a lot of people working on this proposal and have way more experience than me. And not everything that is like intuitive at first sight is actually true or implementable. I'm perfectly happy with this, but I do want you to notice that this is not trivial. However, I just want to also emphasize, like, the answer in line 7 is correct, right? When you query the thing, you get the answer that is true to the point of the program that you're at, like, for example, line 7. But it's still interesting to see that even though you took this meta info object at that point, you get a different answer when you query it down below. Sorry about that. Okay, cool. So we now know a bit more about reflection and also about the pitfalls that you may occur into. Yes?
So can you have denting references in meta world? That's the important question.
What can you have?
Denting references.
So when I use reference...
Now you need like a static code analyzer for that world as well.
Oh my God, you're getting into a very, very interesting domain that I actually want to talk about very heavily. Hi, one second, I think that there's a good chance we're going to have a whole bunch of tool chains and also the topic of how do you signify error is interesting. But I'll get to, but just to address your point, when I use reference, by the way, I don't mean reference as in C++ reference type. I just mean reference to the AST. I just wanted to emphasize that. So this is not a reference type, but yeah. Oh, sorry, there was actually a question here before. Sorry. The what? Again, can you?
Res1 and res2 in your example refer to the exact same object.
They refer to, res1 was taken earlier, and they both refer to the same thing in the AST, which means that if the state of the thing, again, AST, I don't suggest that this is how it's implemented, even though it's most likely is, but I do want you to think of it more of an idea. But yeah, both things refer to whatever the compiler sees as the representation of this object in your program. Therefore, the thing turned from incomplete into complete. Therefore, if you query it, yes. But it's interesting. I could just easily imagine that you'll have some snapshot, right? That you have like a snapshot of the state of the thing, and then even though you ask later, okay. So that's yeah, and that code also works, so feel free to go and scan this QR code and play with this. I need to run forward because, so as I said, tons of meta functions. We're not going to go over each of those. I do want to give you a hint of what exists there so that you can go in and dig and find more. So I could query, for example, again, this code doesn't work because it's not in const eval, but I could basically, I mean, unless you put, like, if it's the main, it's not gonna, so please ignore this port. I have const expr a, and I can query the name of it, and then I'll print the name of it. It will be a, right, not 42. I can have all sort of functions. They can accept info that we already are familiar with and get back all sort of things. So you could get back string view, you could get back the meta info object that I've mentioned, like for example with type of. You can get a vector of meta info. So if I query members of a class, I get back a vector of meta info objects that represent the class members. I can get a Boolean if I ask some questions. Oh, sorry, I forgot you had a question before. So let me just finish this and then. I can get a Boolean if I ask whether this thing is a concept or not, I get a Boolean. I can get the size, like with elements, or just the T. Extract is a very interesting function by itself because it can extract things that not necessarily are in compile time, but you do need to give it the type, kind of like a cast. And it gives you back the type. You could get back also source location in this Protus case, which is if you call the source location function, or member offset if you call the functions that I think it's called, yeah, offset of. I actually wrote it here because it's been modified a few times. But you get some struct that holds the bits and the bytes offset, and then you can query it. So generally speaking, you'll get either meta info or vector of it, or string view, or bool, and the rest of more sporadic cases. Yes, what was your question? Sorry.
The meta objects, are they tied to the lifetime of the compile unit that they were resolved with, or how does that work? Like if you have your header that is complete type, it kind of depends on the inclusion of the complete types header beforehand.
So, okay, there's multiple things. First of all, there is dependency as you know it in like code generally. Like if you include a header and you try to reflect on things and they're not there, you'd get, think of it as, I think the best way to actually understand how this works is with the reference to the ACCU. So if you included something, if you queried before you included something, then you get the answer according to the place you included at. If you included something that modified the state of something you queried before, you'd see the modified state. So like, for example, if I include a header that adds int a, and I don't know, the class that have a member int a, and I queried at that point, what are the members of, I'll get the members, okay? But if I query about things that doesn't exist, that are not modified later, I'll get the same answer. Like the question is whether your headers that you're including are modifying something that you queried about, because you basically change the state of the objects the compiler holds. I hope that makes sense. So if your includes basically modify anything, then you'll see this will be observable. If you include it just randomly, yeah. Yeah, that is, by the way, I'll show, everything I show here, as was highlighted, is done by the compiler. So once thing gets out of the compiler is not in the game anymore, right? So it can't do anything, basically. So we'll talk about this. We'll talk about this. It's interesting in regards to library linking, etc. We'll talk, I think I have a few slides to address your question with more clarity. All right. Any other quick questions before we move on? Yeah, sorry. Yeah, go ahead.
Suppose that you have a structure described, I want to know all the fields are in there and the types. Is there a meta function for that?
Yeah, it will be the members of. Yeah, and you can call it on class or a struct or, yeah.
And you can iterate on them.
You get a vector of meta info. And then you can iterate on the vector and ask whatever you want. And you can also, there's a like is static data member, is virtual, is etc. So you can ask things on those objects. Okay, so but you really need to go and look at the P2996 paper or CPP reference that would follow, because there's so much there, and I haven't even touched the edge of it. Sorry. 10 minutes. Oh my God, no. Okay. Okay. Can you keep your question for Okay, I do want us to go over a few more things here, so I'm going to fly through. Interesting, in ACCU, I had extra time, but okay. So I've already mentioned this. I want to refer to this very quickly. There's two types of type traits. You can imagine things that already exist in the standard library. Type traits like is something that query. Types that like remove are COV or remove reference, whatever, is things that modify. So we currently don't have anything that, we don't really have things in the reflection proposal that modify, but I think that's actually a very, very interesting thing that we're probably going to get, as I mentioned, as a follow-up papers, maybe for the standard library, all kind of traits that do all kind of things to your types and basically edit your code, but it's not exist at this point of time for good reasons. It's going to be complicated, right? So again, if you're interested, I'd be, most likely you're going to get to my room with your proposals. So please do think of those and propose them. It's going to be exciting times. I wanted to show you a few examples of reflection, in practice, sort of. I'm not going to go over those with too many details because I don't have a lot of time, but feel free to look at the slides later. So there's like a reflection logger. It takes a meta info of a type. So of course you'll have to lift your thing before you call this function. And then you can basically log your types. That kind of resembles to the idea of parsers that I mentioned also. Kind of a sort of a usage that makes sense. I do want to highlight one thing. There's report const expire value function here. So I think someone asked during Jason's keynote about how do you, I think it was Matush actually, how do you debug a const eval function? Well, I guess you don't debug, you can print, but this is not part of the reflection proposal, by the way. It's just something that is in EDG's implementation. Still pretty cool. Again, you can go into the link and play with this. And of course, you can see what you expect to see. This is not code that runs, right? It's not like, it have no main. It's basically a compiler giving you back information. And it gives you the information of, here's a class of a student with the name and ID. Command line arguments. So this is a great example being given by Barry Resvin in part of P2996 paper. Barry is, again, an author and one pretty active one. So here what you do, you basically have a clap. Think of it as some utilities that you can use and you inherit from this clap to get this functionality. But basically you define this struct args, and you need to know, basically when you define, you need to know the types of the args and the possible flags. And you define this option, which is kind of like an optional thing with additional abilities. And once you define the struct called args, you basically can parse things from, being passed to your main, and that's pretty awesome. You only have to give, again, what you need to give is the possibilities of things, of args that you can get and the possible flags and their types, just like you would with things like, with Python library. But eventually you'd be able to parse that, and that's pretty cool. And function param names. Okay, I have 10 minutes. I wonder how am I going to do that. Okay, let's keep this example. But imagine that you have, imagine you have a function and you want to print the parameters of this function. You want to know what are the names of the parameters. So in this function, I have int a first and int last. And I also have some definition. There was a declaration, there's a definition, and the function is, I query what are the params of this thing. So I can query before I gave the definition, and I'll get the name first last in the declaration, as in the declaration, and then I can query after the definition and get the names of, as the ones they appeared in the definition. Sorry, I don't know how to jump. Oh yeah, N and ln, right? These are different answers, because first I declared and then I defined. That is a very interesting thing, right? Because basically that means that in different parts, in different points of my program, I may get different answers. We already saw that in the previous example. It's very interesting for function param names, specifically because we don't have limitations in the language on those things, right? You could have multiple, you could have declare foo int, you could declare foo int a, int b. You could declare foo int latitude and like was mentioned in the keynote by Jason. You could do, and these are all the same function. However, they are not. You know, if you can observe, or at least they don't represent the same thing. If you can start observing them. So this problem was actually not spotted by me. It was spotted by the authors of this paper 3096, which introduces a few options that I actually talked more about in ACCU, but now I don't have time for. But basically the question is, what are you going to do when you get different names in different declaration, let's say even, or in declaration definition? Are you going to not compile, basically? No, you know, if you try to reflect on them. Are you going to enforce consistent naming? So if I have different declarations, that means it have more than just don't compile. It can, like, I don't know, give you some fix your names, whatever, error. And then you could also have maybe mark this by some attribute that says, I'm fine with this, don't worry, I don't mind. And then what can you return? Assuming that it is fine, do you return the last? I guess that makes sense, or the first. You know, the names that appears in the first declaration, the names that appear in the last. So the whole thing was explored and actually is still being explored by the authors of this great proposal, Adam and Walter. And we're going to discuss this in Library Evolution as well, because this requires a solution. But long story short, keep this idea in mind and then think about what happens when you have a code base and you have all those, you know, requirements, let's say consistent naming, and then someone new to the company come by and they don't know that you're using a reflection-based logger library that requires these. Because these are not something that C++ requires. These are something that maybe will require in order for you to reflect so that the logger library would work. And then they just add a new declaration that doesn't have consistent naming. And now your whole code base doesn't compile, or your whole code base behaves in an unexpected way. And this is really interesting thing to think about. How does code evolve? So I called it forward compatibility here. I don't know if that's like a reasonable term, but I think of it as like, let's say I do make everything work now, I have a guarantee that it's going to work later? And that starts to relate to what the question that was asked here. Let me skip on that. Customization points is an idea that I also talked about extensively in a different talk. But generally speaking, customization point would be how your library and the user code communicate in order to provide some specialized functionality from the user to the library, right? So basically, virtual functions are a very easy example of customization point. Library declares some function as virtual, user override this function, and then you get the implementation that the user intended to. But reflection also being sort of explored as an option for doing customization point, because think about it, how you could basically explore your code and do modifications to it. So like in a way, you could provide, library could provide some code, user would sort of inject, or again, I would mention that there's no injection utilities yet in P2996, but it's something that we consider for the future. But generally speaking, you could inject things from the user side, and when I say user, it's like the user of the library, and that's basically a customization, right? You're saying, I want this functionality. So we'll skip this example, because I have 2 minutes, I've been told. But think about this idea as well, all right? So reflection can actually modify existing code that could be used in order to add functionality, to modify. It's interesting. And last thing I want to talk about is integration between library code and user code. So I have a code snippet here. Again, I couldn't do a QR because the URL was too long, but you can click on it. That's a full project that works with reflection implementation that exists in Godbolt that is not being done by me, being done again by EDG people, and Dan Katz for Clang, by the way, which is awesome. I think this one's in Clang. And thank you so much for them for working on this, because this actually enables us to play with this and explore and get more information. But this is like an example of how you have a library code and you have a user code, and the user code can actually modify the values of a private member, because you could actually reflect by using member of, you could get the private members and you can set them, which is not something you could do with regular code, right? So with great power comes great responsibility. And I really want you to remember that when you write reflection code. I think I'm gonna skip the last slides. I want you to keep in mind that we need to think about the guarantees that we can get from reflection libraries. Okay, we need to think about things like name consistency and things like that. This is still work in progress. There's a lot of discussion on kind of design questions that you saw here and always being debated, and so anything you see here is not final, and it also invites your input. So please, if anything here jumped and you have some thoughts about that, please reach out to me, because I want to hear I want to hear from you. You're the people that are actually going to use that eventually, and hopefully going to deliver something that is going to be usable. So please, feel free to reach out. I do want to shout out a few people. One of them sits here, Bryce, on his phone, and gave a great talk before. Thank you, Bryce. That was actually very interesting. So Bryce wrote a paper and published with Andrea Lostrzandowsku, which is the author of the D language, about generative extensions. So you asked about injection, or we talked about injection, we talked about generating. There's a very basic ability to create a class in the current reflection proposal, but it's open for extensions, and if you want, I'm sure Bryce would be happy to talk about it more. Another name that I wanted to shout out is the ABI comparison with reflection paper by Saksham Sharma. He's basically trying to see if he can do things like hashing ABI using reflection so that we can maybe move forward, because ABI compatibility is one of the things that C++ cares about, and maybe we can have versioning of ABI or things like that, and that could all be done maybe with reflection. And the last thing is the paper that I just heard about an hour ago, and I don't know if Jonathan is here, but it's pretty awesome. So I don't know if you noticed, the reflection proposal depended on stud vector, on string view, and I think initialize a list. I guess the ranges header, there's some iterations, some concepts there. So Jonathan is actually working on a proposal to remove those dependencies for people that don't want to actually pull stud vector, and I think he also deserves a clap, but I don't know if he's here, so. So thank you for everyone.